mic or not? Can you hear me? Can you hear me okay? Morning everyone. Thank you for having me here. Thank you for the great organization and hospitality. It's really great to be here. And thank you Wayne for coming along. It's made me a great pleasure to be here. So I know you all thought the number in the back of your card was for the raffle today, but sorry, it's not. So there is no cars to be won today. Clicker and slides up. Thank you. Yeah. So obviously, being huh? You know, that's weird. Okay. Good. So we're going to start. Okay, so I work with a research institute in Palo Alto. It's called the Institute for the Future. We study the future. We try and give people more, to help people to make more informed decisions about their futures and make good strategies to face the future. We don't predict the future, we always like to say, and if you hear somebody coming from California telling you they can predict the future, don't believe them. Anyways, I also founded a company that's called Qubit Technologies that does virtual reality, and we are entirely focused on virtual reality solutions and augmented reality solutions. Next one. So I'm going to start with a couple of definitions as usual. So 1938, Antonin Artaud was working in the theater, and he defined for the first time in a book about best practices in theater plays, characters, and objects in the theater. So it was the first time virtual reality was used as a definition in the book. Since 1959, computer science kind of like redefined virtual reality. So not physically existing, but made to appear by software. Go ahead, please. So I'm going to start with a little history, and I call this the journey of computers towards mankind. Part one of this journey. So when computers started, we were used to have processing units far away from us. You know, we had huge computers in rooms with air conditioners to have them. You know, but really, you know, computers were far away from us. And as we moved along, computers approached us. You know, we put a computer on our desks. You know, and the processing unit was closer to us, was our PC, our Mac on our desktop. Then we made laptops, and so the computers went from our desks into our bags. And we could start traveling again, moving around. And then, of course, we invented smartphones, and you know, from the bag, they went into our pockets. And then now with wearable technologies, you know, they go on us, on our body. And with implantable technologies in the near future, they will go inside of our bodies. Okay? And so this is what computers are done towards us. But for the first time, next slide please, virtual reality allows us to go inside of computers. Okay? Allow me to say that. We go with our avatars inside of the computer world. Next please. This is also an image from the Matrix. Part two of this journey, a little history. You may think virtual reality is a new idea, but it's really nothing new. This is the first flight simulation built by Edward Link in 1929. Of course, everything was mechanical back then. There were valves, electronics, there was no computing really. Next, please. Then we went straight on to the 60s, and Philco company tried the first experiment with headsets. Many others did. We have Sensorama is a kind of first experiment to have an immersive movie-like experiences with multiple sensory inputs. 1962 by Heilig. And then Eric Howell in 1964 actually worked on the first version of the stereo vision. This is the same technology which is inside the Oculus today and in any headset. What allows you to split the vision into two and feel immersed in virtual reality and see in 3D. Next, please. See, virtual reality was very popular in the 60s, at least in research labs. This is Sutherland. He experimented with his head-mounted display that, you know, he had sensors, you know, the first early day sensor that would allow to track movement. Right, please. And 50 years later, So that's how long it takes for a technology to come through. Here we go with virtual reality headsets. Next, please. But in the meantime, a few more things happened. And they happened mainly over the internet. This is Maze World, 1973, is the first multiplayer. This was actually in ARPANET. It's the first version of the internet done by that. The first sensor gloves, 1977, for the touch. Habitat, 1983, this was Lucasfilm. This was the first example of a virtual environment for people to live in and to experience socializing. It's the first example of a 3D chat, which is something quite popular right now. Active Words, 1995, again, a virtual world. So a 3D online interactive environment where people can meet up and interact with each other. The first virtual city in 3D, Helsinki, 1998. It's kind of like a precursor of Google Maps. Okay? And then finally, Second Life 2003, super popular virtual world that really started bringing virtual reality more on the media and started having lots of users come online and participate in this creation of a fantasy world that is entirely synthetic and created by people. And we had some roadblocks. We always have roadblocks. In particular, 4 main roadblocks, one for each police car. Processing power, scalability, interoperability, and Wayne knows something about this, and usability. These are big problems to solve, especially when you have, when you have a new technology, when you have a technology that needs a lot of processing power and a totally new environment to operate. Next, please. Actually, we have to go back one. Yes, this is part 3 of my journey into virtual reality. What happened behind all of this is actually a great shift that was theorized by Paul Barron in the early 1960s. Paul Barron was one of the founders of the Institute for the Future, by the way. And next, please. He began imagining this, that we would go from centralized to decentralized and finally to distributed systems. And this is what really is happening behind the curtains of our computing experience, computing history. Each of these network architectures generate a different type of experience for the user, or allow to create a different type of experience for the user. Centralized systems generated mass experiences. Decentralized systems generated social experiences. I'm going to give you some examples of those. And distributed systems, where we are now, generate ambient experiences. The Internet of Things is an ambient experience. It's around us. It's computing everywhere. Virtual reality is an ambient experience. So it's us inside a virtual environment which is around us. And this is what's going to happen in the next 10 years. This is first example, obviously, of mass experience, the TV. The telephone, next please, was also a mass experience, a centralized mass experience. This is originated from decentralized system. It's the social experience, right? Just people looking for the Pokemon Go thing. But this is also originated from social networks. That's the Arabic Spring. It's an image from an Arabic Spring protest, which originated initially from content posted by people on social networks. So these experiences were possible because we had this change in how network systems would work and their system architecture. So VR is really what we call an ambient experience. Next, please. A few things about virtual reality that I want to share with you that I think are important pillars behind this technology. 360 degrees of movement. For the first time, virtual reality allows us to move inside an environment with 360 degrees of freedom and using a new kind of interface next to it. This new kind of interface is the avatar. And funny enough, the avatar is similar to our body. Our body is the first kind of interface we use to be in touch with our world. We have senses, and we have really tried, this is a crazy Russian project, 2045. It's recreating a humanoid avatar where to transfer our brain and personality in the future. Okay, this is some crazy project. But we have avatars today in VR, which are a lot less advanced than that. And they allow it, our avatar is really our identity, our digital persona inside our virtual environment. And it's really important because for the first time we can see through our avatar either a copy of ourselves or a different ourselves, in different form. And this already is quite an important experience to have. Go ahead, please. This is me. A little bit of retouching maybe, but you can scan yourself today. You can scan yourself very easily. And you can get your avatar looking exactly like you. So you can then be yourself inside a collaborative environment. Go ahead, please. Presence. It's extremely important to understand this. We are used to have our online presence represented by a green dot or a red dot if we're offline, or through a video. We use Skype, we use video conferencing. But that always keeps a screen and a camera in between us and the others. Virtual reality allows us for the first time to share the same space. And this allows us to do that, to collaborate, model things together. Let's go ahead, please. This is a bit volume now. Thank you. This is an example of a collaborative VR environment, okay? He's using hand controllers, these two. They have headsets on in reality, but they meet up in a shared space where they can collaborate, as if they were in a meeting room, okay? So this is immediately shows you a powerful application of VR in business. Thank you. Again, some videos of things you can do in a VR shared space. Now, don't look at the graphics here. It's not about showing you, really great graphics, game-like graphics. It's about having a 3D collaborative system that runs online and on any computer. Okay? Because obviously, if you have a super powerful computer and all the gear you possibly can buy, then it's easy to create experience. Here we're showing how you can mirror your facial expressions onto your avatar. Okay? And this happens using sensors, 3D cameras. This is how you can simulate movement. Okay? And this is very important. I mean, facial, you think, facial expressions, what's the big deal about that? Once you have an avatar looking like yourself, what really makes the others feel it's you, it's the expressions, the facial expressions, the movement, your attitude, your behavior. It's not just the image of yourself. It's how you behave, how you move. Okay? This is, again, an example of how you can collaborate in a virtual space. Let's move on, please. The sound, please. What was happening here is to show you what happens when you have 3D sound around you, okay, and the effect this does to you. Can we go to the next one? This is another demo of ambient sound, spatial sound in VR. What you can do with it. Sound is extremely important to immerse yourself in an environment. As if you were there. And computing in all of this is augmenting itself, I like to say. By the Moore's law, computing is becoming more and more powerful. So all the processing power we need to power up these experiences is really coming up. It's just a matter of time and a short time. You may have seen that lately new types of very powerful laptops, video cards are coming out very quickly on the market. And virtual reality is really a driver for that, because virtual reality uses a lot of bandwidth, a lot of processing power, and it's really pushing computing to augment itself continuously. Go ahead, please. We already have this in our labs. This is a quantum computer, by the way. Go ahead. And another thing I'd like to share with you about VR is that once you're inside a synthetic environment, you become fully traceable. Anything becomes fully traceable. We trace people, we monitor reality using sensors, cameras. The Internet of Things is putting processing power and sensors everywhere in every object. But in VR, because it's a synthetic environment, everything is essentially traceable. Anything you touch, anything you do, how much time you spend doing something. So it's the ideal environment to monitor what's happening, what people are doing, and tracking things. Whether you want to track what people buy in a virtual shop or what people do in a training session. Next, please. Some example of how you can augment reality. That's the other big topic next to virtual reality. Okay, augmented reality is superimposing virtual elements in our reality. I'm sure you've heard of this many times. Let's see some example of this. This is Hatsune Miku. It's a Japanese pop star. The only thing is that she doesn't really exist. She's just a hologram. Next, please. She does concerts like a real pop star. And the way she behaves, she acts, what she sings, how she dresses is entirely decided by her fans, but through an up-voting, down-voting system. So people create their own idols in virtual reality, and they make them appear in the real reality as well with augmented reality. And so this is a real concert. This is another thank you, provocative video of mine. This is an author I always like to include in my presentation. His name is Keiichi Matsuda. He's a video artist, and he creates these videos where he shares his visions of the future. They're a bit extreme, of course, but they're made this way just to provoke something, obviously. And this is an extreme vision of how augmented reality can become, where you're overloaded with information. You have your virtual assistant, coming out in given moments and telling you what to do. And in this hyper-augmented environment, we will need to learn how to filter things and how to manage all the information that's around us at all times. Let's go ahead, otherwise people get too shocked on this. A couple of things on the future. Let's go ahead, please. From similar to real to better than real. And this is something everyone should really think about. Because VR is moving fast, becoming better and better every year. Computers, as we said, are more powerful and are able to create more compelling and similar to real experiences, up until a point where virtual reality will become better than our reality. And how this will happen is because at a certain point, we will be able to really connect to synthetic environments, not just by using these bulky headsets and awkward devices we need to immerse ourselves today in this digital world. But we will connect our brain directly to a new form of sensors, which will be our avatars sensors, our avatar hands, our avatar eyes. And when we will connect our brain directly to a synthetic environment, this will happen. I mean, biological computers are already out there, and new forms of connecting the brain and exchanging data are already out there. Labs, of course. But this will make the experience better than real. We're also working on network infrastructures, and there are platforms today on the market, open source platforms, that are redesigning how the internet is made. We're used to an internet in 2 dimensions. Flat screen, a a web page, pictures, videos, but it's still 2D. Now we're heading towards a new breed of web domains that are 3D domains. So from HTTP, we use hi-fi. That's the prefix of our new 3D domains. And once you hit on a hi-fi domain, you will enter immediately a 3D space instead of a 2D web page. So when you add, just by adding one dimension to the internet, what happens is incredible, because the number of things you can do just by adding one dimension are truly incredible. Next, please. So an internet in 3D, new possibilities, new affordances, new experiences. Next, please. Unprecedented, engaging, participatory, real-time, interactive content. This is the result of adding, to sum it up, of adding one dimension to the internet. Okay? Okay, yes, this is about connecting our brains, and when this happens, you're just gonna choose the red and blue pill like in the Matrix. Thank you very much.